Hi everyone, I'm going to talk about the experiment for paper chromatography of gel ink pens. And what we're doing in this lab is we're trying to use paper chromatography to figure out how many different inks are in our normal ink pens, and then use that information to calculate something called the retention factor or RF values for each of the parts of the ink. Chromatography is just a method that we use to separate mixtures into individual components. In this case, we're doing it on paper, so that's why we call it paper chromatography. You can do it in other instruments as well, like a column or other bigger instruments, and so those would be called column chromatography. So this is a pretty common lab technique that you'll learn in undergraduate training, and you can use it for a lot of different things. So for example, if you want to test your water for contaminants, ions, if you want to determine whether drugs or cosmetic products or other pharmaceutical products are pure or not, as well as these other applications listed here. They have two different components to it. They're called a mobile phase and a stationary phase. A mobile phase is a phase that moves during the experiment. So this could be a liquid or a gas. And then the stationary phase is the phase that stays fixed during the experiment. So it could be a solid or semi-solid. Now, the way the mixtures are separated is shown in this diagram right here. So for example, you have a piece of paper. You would put it in a container like a beaker or a specialized container for chromatography. And you will then put a sample, like in this case, this green dot right here. And you would put a mobile phase, which is a type of liquid in this case. And the idea is that the liquid will interact with the stationary phase, which is the paper, and it will move up. And this is due to what we call capillary action, which is a type of intermolecular interactions that occur between certain types of liquid and certain types of solid that made up the paper. Okay, so over time, this is going to climb up. Now, what happens is that when the liquid, in this case, doesn't have to be water, it could be anything other than water, will climb up, it will separate out the components of this green ink. So it turns out the green ink is actually composed of a number of different pigments. And here we have 1, 2, 3, 4, 5 different type of components. And we can see that the purple component here travels the furthest because that component interacts well with this mobile phase. Whereas the gray component travels the least because it has the least amount of interaction with that mobile phase. In fact, it has the strongest attraction to the stationary phase, which is the paper, so it doesn't really move that much. Okay, that's the experiment. And what we are trying to do is just figure out how many different components are there, and then determine retention factor, which is just how far that spot has traveled relative to what we call the solvent front. So the solvent travels all the way to the top here. The purple spot is pretty close, whereas the gray spot is really far away from that solvent front. So to calculate the retention factor, or RF, is divide two numbers. The first number is just the distance that we measure from the starting point to the center of the spot. So for example, if I want to calculate the purple one, I would take the measurement from the beginning part to the center of that purple spot. So that would be one distance. That's called D. And then we would take a second distance measurement, which is from the starting point to the solvent front. That will be called F. And then what we do is we divide D by F, and we get our RF as a result. So you can see that because the F is always the largest number, the D divided by F would be at the most equal to 1, but usually it'll be some kind of a fraction or a decimal, okay, less than 1. So here's an example. I have a chromatogram that I've measured distances to the center of each of these spots, and I'm interested in this case to find the RF for the purple part of the ink. So the purple part is right here. I measured that distance from the beginning, and that's 6 centimeter. And I measured the distance from the origin to the solvent front, and that's 10 centimeter. So my RF is just 6 centimeter divided by 10 centimeter, which is 0.6. Okay. In your lab report, you're going to have to calculate the RF. You're going to have to identify how many spots exist in the sample that we're going to be working on.